On this lesson, we are looking at the reactions of organic compounds. The reactions of organic compounds can be classified into 4 different groups. The first one being oxidation, the second one being substitution, the third one being addition, the fourth one being elimination. Each and every one of these reactions which these organic compounds undergo, they can be classified and they can be distinguished amongst each other. There are certain things that are unique to each one of these reactions. So we're going to study each one of these reactions in detail to try and understand what it is that makes a reaction to be an oxidation reaction, what makes a reaction to be substitution reaction, what makes a reaction to be addition reaction, and what makes a reaction to be elimination reaction. And therefore, when you look at any reaction, you should be able to tell to which group does it actually belong to. Now, oxidation reactions are reactions that involve oxygen. Whenever you have an alkane that is introduced to oxygen gas, therefore you will create carbon dioxide plus water. So this is the reaction that you will have during an oxidation reaction. These are quite rare in examinations for now, so we are going to focus on the rest of the 3 in more detail. But oxidation is also one of the reactions that are part of organic chemistry. The substitution reaction. What happens is that when you have a saturated compound, you cannot add anything to it. So since you cannot add anything to it, you have to substitute. Because if a saturated compound reacts, you cannot add, but substitute. So how would we know when we are dealing with a substitution reaction? We are going to look at a reaction in the form of A plus B gives you C plus D. And we're going to look at the fact that the reactant that we are looking at must be a saturated compound, so that we know that whatever that is added here, there is no way that it will be part of this saturated compound, because this thing is already saturated. It cannot accept anything. So the only possible way to create a product different from this reactant is if you take something out of this A and put something from the B and substitute it in the A. So we know that it's a substitution reaction when we are dealing with a reactant that is saturated. Because when your reactant is saturated, we know for a fact that it cannot take anything in. So that is how you know when you are dealing with a substitution reaction. When you're dealing with a substitution reaction, we are expecting that also the products will be saturated. The products must also be saturated, because we are just substituting something out of this, putting it there, something out of that, putting it there. So at the end, we want to see a product that is also saturated. So these processes, they said to be happening very slow. They happen slow. All right, they are not spontaneous. They need energy. They need heat. They need heat. So it happens at a slow rate. This is called a reaction condition. This is the condition that allows this reaction to happen, is that it needs heat. It needs energy, enthalpy. So let's recap what we talked about. This is the second group of reactions that an organic compound can undergo. This one is called substitution reaction. Now, the substitution reaction, right, it occurs when a saturated compound, in this case A, reacts in order to create products. But because it's saturated, it cannot take anything in. It has to substitute something it has with what it doesn't have. And I'm going to give you an example of this. Imagine if you had a saturated compound like an alkane. An alkane is saturated. A simple alkane could be propane. And this is now reacting with water. What would happen is that because we cannot add anything to the alkane, we then need to substitute one of the members that already exist in the alkane with one of the members that exist in the other side. And therefore, we would have an alcohol. This came from there. It substituted this one. And then you have hydrogens there. See that? Now you have an alcohol. By doing this reaction, we have created an alcohol by substituting one hydrogen. Now, when I take out that one, remember, this hydrogen will remain and this one will remain, and therefore they will create a secondary product, which is H2, hydrogen. All right. So we can see that this process has produced hydrogen and an alcohol. So this is an example of how substitution would occur. Because substitution is a process whereby a saturated compound reacts with another compound. And because you cannot add anything to a saturated compound, the best thing you can do is you can substitute one of them. And there's a law that we can follow in order to substitute. When we do more examples and exam examples, I'm going to teach you more on the laws that we will follow in order to substitute or to see how substitution has occurred. So for now, this is how substitution actually works. I hope this makes sense. And let us look at different types of substitution reactions. You have halogenation. Halogenation is a substitution reaction because it's an addition of a halogen. It's an addition of a halogen. So when you have an alkane that is reacting with a halogen, right? And this must occur. Remember, we need heat, delta H, enthalpy. What will we get? So what is a halogen first? A halogen is represented by X, and it is in group 7 in the periodic table. The halogens that we have are your iodine, your chlorine, your fluorine, and your bromine. These are your halogens that we have, the ones that we'll be using in all of organic chemistry. Now, if one of that is added to an alkane, like I gave you an example with, we can use ethane. When you have an alkane, and maybe let's say we're dealing with bromine or bromine, it's going to be Br2. It will be Br2 because it will exist as a diatomic molecule. It won't just be Br, it will be both of two of them, like O2 when we did oxygenation, oxidation. Now, this reaction cannot occur in such a way that one of these gets inserted into the alkane because the alkane is already saturated. So we know that this will be a substitution reaction. Therefore, we're going to substitute one of the Brs with one of the H. Then you will get then what is this? This is now a haloalkane. So you have a haloalkane plus the H and the Br, remember they substitute. And then you have a secondary product, which is HBr. I should put a reaction there, but then I don't have enough space there, so I hope you understand. Now, this is now a hydrogen bromide, right? So this is your secondary product, but this is your major product. This is what we're focusing on. And this is a process called halogenation, which is a substitution reaction. And it's one example, right? It's one example. Another example is called hydrolysis. Let's look at hydrolysis. Hydrolysis or hydrolysis. It is a process where you are adding water to a haloalkane. If you have a haloalkane and you add water, you will get an alcohol plus a secondary product. So this process is then called hydrolysis, the addition of water, right? There's another way of doing the addition of water, which is called hydration, which we'll talk about, because that one is not a substitution reaction. In a substitution reaction, the addition of water becomes hydrolysis because it's substituting. It's not hydrating per se, which will make more sense when we look at hydration. So for now, what we have is a haloalkane. For an example, what we had Br. So we had bromo ethane. With bromoethane, you can add water. And by adding water to bromoethane, the bromo and the OH will substitute. Then you will get an alcohol, which is now OH, where this came from that. And then you have your H, plus the H that remains there, and the Br, they give you the HBr, like the HX that we talked about. And then this becomes the process called hydrolysis. It's a substitution reaction. It's a substitution reaction because we are going to exchange from a saturated hydrocarbon, or in this case a haloalkane, a saturated haloalkane. We adding water, it's reacting with water, so the OH group gets substituted into the Br group, and then the Br group goes into the space of the OH group. And this process is where substitution is happening. So this is a substitution reaction. It can happen in these ways that I have just shown. So the same thing can happen between a haloalkane and NaOH. You can also have the same substitution, whereby the haloalkane with a Br is going to substitute the OH and the Br. Right? And then let me see, CH3, CH2, Br. And then NOH is the same reaction, but I'm now using, instead of water, I'm using NaOH, which is a slower reaction than this one. What would you get? You would get CH3, CH2, OH, that's an alcohol, plus Na, right? What would that be? NaX, which is in this case Br. So this is how a substitution reaction can occur. And this is called hydrolysis. I hope this makes sense. So let's recap what we just spoke about so far. We have just discussed that in organic chemistry, we have reactions, and these reactions can be grouped into four. One, we talked about oxidation, which is the ones that involve oxygen. Then we spoke about substitution, which is the second reaction that we spoke about. And then we said substitution can occur when you have saturated reactants and you will get saturated products. And then I gave you two different types of substitution reactions. I gave you halogenation, which is adding a halogen. And then I also gave you hydrolysis, which is you are adding H2O, or let's say something like a NaOH, like I gave you the example, right? And you are adding this to a saturated compound, so that makes it a substitution. And so far, these are the two that we spoke about. I hope so far you understand these two reactions, especially substitution. But then as we do more examples, it will make more sense. Now I want us to go to addition. Let us look at addition reaction. Now when it comes to addition reactions, there is a simple a transition from substitution, is that you are dealing with something that is unsaturated. Firstly, you can only add on something that is unsaturated. So you are going to take an unsaturated compound, and then when you attach it to, or when you react it with something else, therefore you are allowing the double or the triple bond to be broken, right? And you are going to create products that are more saturated, right? This is faster than the substitution reaction, and it's usually spontaneous. So look at it like this. On the substitution, we spoke about unsaturated. We spoke about saturated, meaning we took something that didn't have a capacity to accept anything. So now addition happens on unsaturated. So it has to be alkenes and alkynes, because these are the only ones that are unsaturated. So now the only reactions that are called addition reactions that can happen is if they are happening from the alkenes or the alkynes, right? Because it's the only way. So we're going to focus mainly on the alkenes because that's the one that you will see mostly. But then the addition reaction happens simply by identifying that the first reactant is an alkene, is an unsaturated compound. Therefore, you know that whatever happens next is going to be addition. Right? So, again, we still have halogenation. So, when you have an alkene, and then you add a halogen, when you have an alkene and you add a halogen, you will get a process called halogenation, right? And your product will be a haloalkane. So let me make this a bit more clear. Let's talk about addition. This is how you will find it in the exam. They'll put an alkene at the center here. They will put an alkene, and then they will show you different arrows moving away from the alkene, right? So when you have the addition of, let me move in this direction. Let's say you add a halogen. If you add a halogen, the process is called halogenation. And when you do halogenation, your product will become a haloalkane. Alkene undergoes halogenation if you add a halogen to it, and then your product will become a haloalkane. So that's one addition process that you can see, and how you can identify it from any angle. These are all the factors. This is halogenation. To know that it's halogenation, is the reactant an alkene? Are you adding a halogen? Is your product a haloalkane? If those fit, then the process is halogenation. Now, I spoke about hydration. What happens when you add water. What happens when you add water? Remember H2O. The process is called hydration. And the resulting product of hydration becomes what? So you can take a guess. Alcohol. Because you're going to add a hydrogen and an OH to an alkene. You're going to break a double bond to create an alcohol. This is literally how the exam is going to show you. And you just need to know what is what. And this is how you know. By watching this video again and again and again, taking it back, asking questions. So, what else can I add? I've added a halogen. I've added water. I can also add a hydrogen. If I add a hydrogen, the process is called hydrogenation. If I undergo hydrogenation by adding a hydrogen from an alkene, what will I get? An alkane, a saturated alkane, because I will break a double bond and I will add 2 hydrogens, and then I will have an alkane. I will repeat this diagram but with only structural formulas so that you can see how these can actually be seen if you're given structural formulas. And then that's how we'll have 11 alkane. Now, there must be one last process that we can do. We can add a hydrogen and a halogen at the same time. We can add an HX. We can add a hydrogen and let me show you how. We can add an HX, like hydrogen bromide is an example. Or we can add hydrogen chloride. Right? So we need to know what happens when we add HX. X represents all halogens. The process is called hydrohalogenation. Hydrohalogenation. That's the process. And the resulting product of that. Can you guess what happens when you add a hydrohalogenation? You get a haloalkane. You see that? These are the processes that you can find or you can observe whenever you are dealing with addition. When you see an alkene, just know that whatever you can do to an alkene is addition. Right? Whatever you can do to an alkene is addition. Now, all of this, if you reverse it, it's elimination. If you reverse any of this, it's called elimination. For an example, if you reverse hydration, it becomes dehydration. If you reverse hydrogenation, it becomes dehydrogenation. If you reverse hydrohalogenation, it becomes dehydrohalogenation. So the process of elimination, which is the next reaction type, it is the reverse of addition. Nothing new. It's the reverse of addition. Okay? And then another thing that we have is cracking. So cracking is a different type of an elimination reaction. So I'm just going to list them so that you can remember them and have them as a visual reference. Remember, elimination is the reverse of all the addition processes. Okay. Now, you have the first one, which is hydration. Dehydration. This is elimination of water. It's called dehydration. And then you have the second one, which is hydrogenation, the addition of hydrogen. Dehydrogenation. This is the elimination of hydrogen. Right? The third one, you have the addition of a halogen and a hydrogen. All right. So we have dehydrohalogenation, HBr or HS. When you add a hydrogen and a Br or a halogen, you get HBr. We get hydrohalogenation. When you reverse that, it's dehydrohalogenation. And the fourth one, we do not have. This one I'm about to write it's not part of the reaction because we had halogenation. We do not have dehalogenation. We don't have the removal of a halogen. No? So we don't have that. What we have is cracking. Cracking is when we have an alkane of a big chain and you break it down into different other alkanes of smaller chains. This will be seen at the end of organic chemistry, cracking. We'll be talking about plastics and all of that. But yeah, these are the elimination reactions that you can expect. And I hope they make a hell of a lot of sense. Right? So dehydration is the reverse of hydration. Dehydrogenation is a reverse of halogenation, of hydrogenation. And then dehydrohalogenation is the reverse of hydrohalogenation. And then the last one is cracking. All of these are called elimination reactions. So these are all the different types of reactions that you can expect in organic chemistry. There is nothing else. These are all. And if you can just go back and rewatch this video again and again and again, you can always make sure that you get the basics of how this works. So I'm going to make a more detailed video giving you examples of each and every one of these reactions. How dehydration occurs, how dehydrogenation occurs, how dehydrohalogenation occurs, perhaps even how cracking occurs. So for this session, make sure that you understand each and every one, each and every piece of information that I shared with you. From the beginning, we spoke about let me just do a small recap with you. So we spoke about reactions of organic compounds. I mentioned oxidation, substitution, addition, elimination. These are the reactions that we have when we deal with organic compounds. And then I gave you an example of an oxidation reaction, that it is a reaction that involves the addition of an oxygen, which is unique. That's why in Nailawa. And therefore, we spoke about the second one, which is substitution reactions. And I said substitution reactions only occur when you have saturated compounds, right, as a reactant. And you are trying to react them with something else. You cannot add to them because they are saturated. What can you do? You can only substitute. Therefore, an example of that is if you have A and it's saturated and it reacts with B, B can only substitute something in A in order to create even other saturated products. So that's the first one. That's substitution. And then an example of substitution reaction or a substitution reaction is shown here. You have an alkane that reacts with water and the OH gets substituted with the H in the alkane. Therefore, you get an alcohol. You get an alcohol and a hydrogen. All right. So this is a process of substitution whereby we cannot add to this alkane because it's saturated. But because it's reacting with this water, then this substitution can happen. So this is an example of a substitution reaction. And this reaction was used as an example. I also give you another example. I said halogenation. Halogenation is a process of substitution. Why? Because halogenation often happens between an alkane and a halogen. You are adding a halogen to a saturated alkane. So the only thing you can do is you can substitute the H, one H, not a specific one, but one, right? And there is a law that we can use in different types of reactions, which I'm going to teach you. And then you can just substitute, right? As simple as that. You substitute in order to get the product. So because there's substitution occurring, and substitution is forced because this is saturated, you cannot accept anymore. Therefore, it's called a substitution reaction. So halogenation is a substitution reaction. And then you have another substitution reaction called hydrolysis or hydrolysis, whereby a haloalkane reacts with water, and therefore the halogen part of it gets substituted by the hydroxyl group OH in order to create an alcohol, right? And this is called substitution. Why? Because this haloalkane is saturated by itself. And because it is saturated, there is no way that you can add anything more to it. You can only substitute. Therefore, hydrolysis is a substitution reaction, and that's another example. So the two examples that we had was oxidation. The reactions that we have is oxidation and substitution. Substitution, we spoke about two types of substitution reactions. Halogenation is a substitution reaction. Hydrolysis is a substitution reaction. And those were the substitution reactions as we discussed. Then we spoke about addition reactions. We said addition will occur if only we are dealing with reactants that are unsaturated. The reactant have to be unsaturated because if we are to add, we need to break down some bonds. So we can only deal with alkenes or alkynes. So I said we're going to look at alkenes mainly because that's what we are focusing on in our CAPS syllabus. So if you take an alkene and you add a halogen, then you get the process called halogenation. You get a haloalkane. Now I went into even further detail to explain these different types of addition reactions. I said if you have an alkene, in your exam it will be given like this. An alkene will be placed at the center. You have to identify that. And then everything that is done to an alkene is going to be addition. And these are the four major types of reactions, addition reactions that you will find. The addition of a halogen is called halogenation, and the result is a haloalkane. The addition of water is called hydration, and the result is alcohol. The addition of a hydrogen is called hydrogenation, and the result from an alkene will be an alkane. And the addition of a hydrogen and a halogen, addition of a hydrogen and a halogen, HBr, HX, HCl, HFl, any one of those halogens, it's called a hydrohalogenation. And these are called addition reactions, four of them. And then I explained that if you reverse each and every one of these reactions, except for one, if you reverse all of them except for the addition of halogen, because this one is not part of an elimination reaction, then the rest of them, they become elimination. Because elimination is just the reverse of these. And then we talk about hydration becomes dehydration. Hydrogenation becomes dehydrogenation. Hydrohalogenation becomes dehydrohalogenation. And in the space of halogenation, we now include cracking, where we take a big alkane and we crack it down into smaller alkanes. And this is called elimination. So that is the summary of what we spoke about in this video. And make sure that you understand each and every part of it. Watch it again. And watch out for the next video where I'm going to go into detail and discuss each and every one of these. And then I'll also go into esters so that we can be able to be familiar with every reaction associated with organic chemistry and be ready to solve our exam papers. And then after we are done with reactions, we will then go to the next part, which is intermolecular forces.